About 1 month ago, Mark from Winky's workshop, he posted a video where he explains from the absolute beginning to the absolute end how he cut threads on his lathe. A really well made video, and in the description there is of course a link. And I have to say that it's always a joy to watch Mark's videos. Always well made and very informative. But he cuts imperial threads. So the plan for the day is to make the same kind of video, but of course metric. And I will explain how I do it. It is not the official system, and I'm pretty sure if Jupai or, for example, Stefan in Germany see me doing, they're gonna kick me out of the shop. But you will see that it works. And I will do it here on the Celtic lathe, because I had a comment from Palm2893, and he is the proud owner of a Celtic 20 lathe, which has exactly the same layout than this one, but the 20 is bigger than, for example, 14, 20 bigger, 14 smaller. So Palm, this is for you, and of course also for everyone else that wants to cut some metric threads on his lathe. And let's start with a plan, which normally I never do, but for this time we'll make an exception. Right. We have to make a part, diameter 16 millimeter, and we need over a length of 20 millimeter here, 15 millimeter of metric 10 threads. And the material we're gonna use is this 16 millimeter round bar. Now this is a special make something steel, so I don't know, we'll see. So the outer diameter is correct, we don't have to touch. All we have to do is over 20 millimeter here, cut a metric 10 thread over to the lathe that we can find right here, I think. Yeah. Because we need to cut 20 millimeter, but to make sure we're gonna face it a tiny bit, so the stick out, let's say for example 10 millimeter more than we need, 30, maybe 35, not too much. Because round bar is never round, I always wiggle waggle a little bit to find the smallest spot, the smallest diameter, just to make sure it is well held in the chuck. And before we start cutting, first we're gonna set the top slide at the right angle. Now it's not really necessary to do it now, but everything that's done is done. Plus you will see that it will make it a tiny bit easier. Now because your lathe is different than my lathe, than the other one's lathe, is it 60 degrees or 30 degrees? The angle of a metric thread is 60 degrees, which means this angle here, 60 degrees. To cut the thread, we're gonna set the top slide at the same angle as this one here. Now, it's a little bit confusing sometimes. If we start from the idea that this is 0 degrees, yeah, this is the bed of the lathe. Cross slide is at 9 degrees, 90 degrees. And the top slide we're gonna set at 60, because 90 degrees, we cut this angle in two, yeah, 30 degrees that way, 30 degrees this way. 90 mean 30 is 60. Now we have to be a little bit careful here. For the moment, the thing, the top slide, because it is on top, is set at 0 degrees, which means in line with the bed of the lathe. And we said that this is 90 degrees. So 60 degrees will be somewhere over here. But on this lathe, it's maximum 40, 45, and then we can't read anymore. Which means they installed a mark that you hardly can see right here. This mark is installed at 45 degrees. If we set back 0 here, we see the mark 45. Which means I put my 0 over here. Now we have 45 degrees. 50, 55, 60. Because 60 degrees minus 45 is 15. So here we're good. This is a view on the USSR lathe. And the difference here is that the degrees are marked on the fixed part. On the Celtic it's on the moving part. So here I have to set it at 30 degrees and not 60. The top slide is now fixed in place. And to make sure we have the maximum rigidity, we're gonna set here the dovetail in line, which means not too much stick out, because here it's gonna move a little bit maybe, and of course also not too much stick in. So I always set it in line, and very important, I set it over here, the dial at 0. Setting the top slide is something, if you're not familiar with, take your time and think a little bit about it. Because yes, I have seen on YouTube some hobby machinists cutting the thread at the wrong angle because of the top slide was at 30 degrees and not 60. All that's left to do now is set the cutting tool at the right angle for turning and facing, and we can face the work. And without moving the carriage, we of course also set the 0 right here. Now, this dial, as you can see, there's a lot of play. So what I do, I push it that way inside in the workpiece, and then I can set my 0. And I do this to make it easy, because we need a total length of 20 millimeters. All I have to do is move my carriage to 20, and I know I have 20 millimeters cut. And now we're all set up to start cutting, reducing the diameter to the outer diameter we need to make the threads, which is of course how much? Metric 10. And this is the part where Jew or Stefan will kick me out of the shop, because here I cheat. If you measure a metric 10 thread, it is of course not 10 millimeters. This one, for example, is 2/10 smaller, so 9.8. This one more or less the same, a little bit smaller, 2/10. And of course we need this 2/10 smaller to have clearance to receive the nut. And the nut has always a little bit of play. So when we cut threads, it is not, of course, a point here and a point here, but it's always rounded, outside and also inside. The outside, that is more or less easy because it's just the outer diameter, so not a problem. If I measure here 2/10 less, so I will make this one the same. 10 millimeter minus 2/10 is 9.8 outer diameter. Diameter 9.8. Check. Time to install the thread cutting tool, because we're gonna use it also to cut this little relief. But how deep? If we know that the pitch of a metric 10 is 1.5 millimeter, every rotation the nut will move 1.5 millimeter. Triangle 60 degrees, which means in theory between the tip of the thread and the bottom we should also have a depth of 1.5 millimeter. So if we make this little relief here 1.5 millimeter, we're good. And at the same time I also install my thread cutting tool. And to set the angle right, normal people use this kind of fishtail gauge, which of course I don't have. But with just a piece of threaded rod it also works, of course. All I have to do is back off a little bit, keep it parallel. Oh, escape, come back, got you. Keep it parallel with my workpiece. I put a piece of paper below here to have more contrast, and then you can clearly see, you can't clearly see, but I can clearly see if both of the angles are right. My 2 times 30 degree in relationship to this little piece here. That's looking good. To make it easier for myself, I draw a little bit a line here at 5 millimeter of the end, and I will use this as a reference. And this is of course also where the 0 I had set previously on the top slide comes in handy. So I don't have to look for 0, I already have it. Cutting tool installed and lined out, and the little relief is cut, and I also cut a little relief on the other side. And now we need to know how deep we have to cut. And this is again where Jew will kick me out of the shop, because we do not measure the depth of a thread, we measure the distance between 2 points somewhere using thread wires that I don't have. But as I said, I cheat. Let's make it easy. We know that the theory between this point and this point is 1.5 millimeter, the pitch. But we reduced the diameter of 2/10. And the tip of my cutting tool, now this is not a thread cutting tool, but you've got a point, is of course not pointy, The width of this point is I don't know, you can measure it. I know that for these inserts the radius is 0.2 millimeter, but I'm not using this one, I'm using one homemade. And if you use inserts that you bought on Amazon or eBay, it's not marked how much this flat spot is on the top. So we have to guess. I start from the idea, because we reduced here 0.2 of a millimeter, we're gonna also reduce on the inside 0.2 of a millimeter. So 1.5 minus 0.2 minus 0.2, maximum depth is 1.1 millimeter, right? Now, to check more or less if your cutting tool that you made is alright, you can use the typical thread gauge. You put the point in the thread and you will see light or no light, so that's an easy check. Let's start cutting to a depth at 60 degrees of 1.1 millimeter. But of course I almost forgot. First we have to set the lathe to a thread pitch of 1.5 millimeter per rotation, of course, using these toy levers here. Let's study a little bit what's marked here. This one is for the spindle speed, rotations per minute. No need. Threads per inch. No need. Diameter pitch. No need. This is the feed system. Cutting threads using module. And this one, pitch in millimeters. We need a pitch of 1.5 millimeters per rotation. Yeah? Pitch of 1.5, which is marked here. For video purposes, I will glue some magnet over here if it wanna stick. Right, 1.5, I will camouflage it with. Okay, it will hold. So we need to know the alphabet. We need to do B, D, E, K, 6. Okay. It is of course very easy. We said that we need B, D. This lever we have A and the other side is B. For the moment I will leave it on A. It's easier to turn the spindle by hand. The other one we need D. That's done. What else? In this line we had E. This one. Turn by hand. E. And then 6. And this is in the line of K. And K we can do right hand thread or come on, handle or left hand thread. It doesn't want to. And to make it easier to work, I set my machine at the lowest speed, so this lever in 1. And now that I finished turning by hand, I can set the double gear, which is B. To cut metric threads, we always leave the half nuts engaged, which means we're gonna turn the machine in one direction to cut, retract the tool and wind it back, always engaged. Which means when we stop the machine with the inertia of the motor and all these gears in here, the carriage will move a little bit more and could maybe crash into the right shoulder I left here on the workpiece. So a very handy little trick is of course engaging the half nuts and then starting the machine, and then you check on this dial here. From the moment you touch 0, turn the machine off and then you can see how much further the carriage moved after you stopped the machine. Let me show you. To do the test, I set the carriage far away from my workpiece, and I will bend down a little bit this camera stand so you can see the dial. For the moment I am at 15 millimeters from the zero. So we're gonna start the machine, engage the half nuts, it's here, and from the moment we see here the zero, stop the machine. If I start from the idea that after stopping the carriage moved 1 more millimeter, I think that's very useful information. It means that while cutting and, for example, 1.5 or a half a millimeter before the end of the cut, I can stop the machine and it will continue almost a half millimeter after the end of the cut. So it will not crash in the right shoulder I made here. Let's get a thread. I am 1/10 shy of the finished dimension, but because this tool makes a terrible burr, this outer diameter is now bigger than it was before. So we're going to give it a little bit test fit. It's hard to turn, but it works. Let's measure. The outer diameter is now again 10 millimeters. So I have to take off 2/10 of a millimeter and it will be perfect. As you can see, cutting a thread up to the right shoulder, no big deal. And I think the fit is close to perfect. Now, of course, when you take a closer look, the finish of the thread is not really great. That's because I took a little bit too big cuts and I didn't use oil. When I use oil on threads, it's not really video friendly, so it's a choice to make. Use oil, take small cuts, and finish with spring passes, and the thread will be perfect. Now another one. If you need to make, for example, a bolt that looks like this. This is the outer diameter of the thread. The thread, of course, but not over the whole length. All you have to do is set your 0 on the carriage right here. Start cutting, and when your tool reaches 0, retract. Come back, dial in, cut, 0, retract, and this will be the result. Easy peasy. Now, if you still think that cutting a thread up to a right shoulder is still too stressful, let's do something else. Let's make a little workpiece similar like this one, but with a M6 thread. Uses a pitch of 1 millimeter. So we're gonna set the machine at C, G, here is the 1, 3, K. I will use the magnet again, really easy. This lever will be on the C, C, D, C, and G. Doesn't want to. G, number 3. This one is on K, right hand thread, that's okay, and of course B. As you can see, I installed my cutting tool for internal threads, and I'm gonna start cutting from this side on the shoulder to the outside. Of course, the machine will turn left. What's nice on this idea is that I can put the tool back and way more and clear completely the shoulder we made here. And I made a Sharpie mark right here on the top side, so I'm sure I will always put it back at the right spot when I have the 0. Let's go back. And as you can see now, I'm really close. So this could have been a crash if I was with my tool closer to the work. No panic, put the tool back, spin a little bit backwards. Try again, looks better. Okay, set 0. Dial in 0.2 of a millimeter. Let's cut. Now, come back. as I said in the beginning of the video, of course this is not the way how to cut threads. If you want to do it right, use the black book, the machinist handbook, the Google, the whatever. But I'm pretty sure if you make it this way, to make for example a hook to store your bike, that will work